Okay, so let's look at some common algebraic expressions. Can everybody see my screen? Does somebody?
No, we see you still.
You see me? Oh, stand by. Right. What does an expression not contain? Otherwise, we'd rename it.
Multiplication and division.
Oh, it can have that. It can have that.
An equal sign.
Right. It has no equal sign. No equal sign. All right. If we gave an expression an equal sign and put another expression on the other side of that equal sign, what would we call it? You know, there's an equal sign in it.
Equation.
There you go. Okay. So let's look at this first expression here in exercise number 1. So we have the square root of 25 minus x squared. Okay. And they want us to evaluate that when x is -3. So we're going to plug -3 in. And you're going to want to use parentheses, right? Because that whatever x is getting squared. Okay. So let's just plug that in. Square root of 25 minus, right, -3 squared. Okay. Now, are we going to call this, you know, minus a negative being a positive? Anybody? No, because right, order of operation, we have to do this squaring first, right? So then we end up with the square root of 25, and what is -3 squared?
-9.
Not -9, -3
9.
positive. Anytime you square anything, you always get a positive number, right? There's a minus sign in there just because that was in the expression to begin with. And of course, basically, order of operation, right? We're going to work from the inside out. So 25 minus 9 is 16. And what is the square root of 16?
Four.
Okay, it's one. That's one of the answers. What's the other? It's not just 4. What's the other square root of 16? In other words, what's another number that you square and get 16?
2.
Not 2. 2 squares is 16. 4 times 4 is 16. There's another number that you can square and get 16. -4, right? So plus or minus 4. Right? You always get 2 answers when you take a square root. Hang on to something. Somebody's messaging me. They can't quite get in here. Okay, so again, whenever you take a square root, you get a positive and negative answer. Now, there's a lot of times when we disregard the negative, you know, in the context of something, okay? But let's look at part B here. Why can you not evaluate this expression when x equals 16 or 13? Let's plug it in and find out, okay? So we have the square root of 25 minus 13 squared. So that's a square root of 25. Anybody know what 13 squared is off the top of their head?
169.
169, right? And then 25 minus 169 is
-44.
negative 144. Anybody know the square root of negative 144?
You can't.
That's
You can't
right.
square root a
You cannot
negative number.
take the square root of a negative only in the real number system, okay? You know, you got the real numbers and actual numbers, whole numbers, all that, right? Integer sets. In the real number system, you cannot take a negative square root, okay? So there's no real answer here. No real. And by real, I mean in the real number system. Okay? No real answer. You cannot take the square root of a negative. Because that implies, right? What's the opposite of taking the square root? Squaring, isn't it? So that would mean that if I get some result for the square root of negative 144, I can turn around and square that number and get negative 144. Do you ever get a negative number when you square anything? No, okay? So that's why we can no longer, now later on, in a later section, we'll talk about the imaginary number system or complex number system where you can take the square root of the negative. And that's, if any of you move on to engineering or something, it gets to be pretty handy, okay? All right, let's go down to part C here. And here's where we end up with a common mistake that kids make, all right? So we have this square root of 25 minus x squared. And I know a lot of you try to rewrite it like this. Take the square root of both of those things, and it just simply becomes 5 minus x, okay? So let's test that, right, and show that this is not an identity, in other words. In other words, those two things are not really equal, okay? So maybe we'll test it with, I don't know, x equals 3. All right, so we'll plug a 3 in there just to see what happens. 25 minus 3 squared, right? Let's see if that actually equals 5 minus 3, okay? So we're checking to see if, in other words, when we get done, we should get same number equals same number, right? If our hypothesis is correct. So that's the square root of 25 minus 9 equals 5.2, right? We'll find out. Square root of 16, does that equal 2? Plus or minus 4 does not equal 2, okay? So if you have the square root of an expression like that, you cannot just take the square root, of both sides. Because again, like in our last example, right, that would imply the following, if we thought it would. It implies that if we square this thing, we get 25 minus x squared. So let's find out. It implies that 5 minus x will equal 25 minus x squared, right? Well, let's do that. What does that mean to square something? I should put a square there, sorry. To square something means to do what to it?
Double it.
Not double it.
Define the root number.
Well, just multiply it by itself, right? So this 5 minus x quantity squared, wouldn't that be equivalent to the following? Doesn't that look like what it means when we square something multiplied by itself? And you guys know how to do this. What do we do to evaluate this? What are we going to do this multiplication? What's it called?
Distribute.
Distribute. God, I'm glad nobody used the F word. I think you know what that is. Just going to distribute twice, all right? So let's distribute the 5, and then we'll distribute the negative x, all right? So we get 25 minus 5x, right? Now we'll distribute the negative x. Minus 5x again. And what's negative x times negative x?
0. Oh, no.
Multiply.
-10.
Negative x times negative x, positive x squared, right?
Yeah, no.
All right, let's combine like terms. Okay? That is not our 25 minus x squared, okay? So we can't just take a square root of a binomial like that and split it up and take the square root of each separately, okay? There is a thing we can do. I'm going to give you a quick note because they don't really include it here, and I wish they would. So I'm going to write this, and you should too. And when I write this, on one of your pages here, that means we're going over to a couple pages. See where I have a blank page? It says Notes Workspace. Okay, over here on page 9. So everybody flip there and just jot this down because this is an important property to know. So properties of radicals. What's that mean? What's a radical? Radicals are just like that square root symbol thing, right? And I didn't call it properties of square roots because this can apply to any like cube root or fourth root or anything else like that, right? So let's say I have the square root of some number a times the square root of some number b. if I'm multiplying two square roots like that, I can then combine them under one radical. Square root of A times B. This should be kind of familiar to you, right? And then, by the way, equal signs work both ways, don't they? So if I have something like this thing on the right, could I split it up and make it look like this thing on the left, right? Correct? So it works with multiplication. It also works with division. If I have the square root of A divided by the square root of B, I can rewrite that as the square root of A divided by B. And backwards, okay? And backwards. Now the following is important, okay? This is what you cannot do, right? If I have the square root of A plus or minus the square root of B, it does not equal the square root of A plus or minus B, okay? We saw that in that last example. So please don't make that mistake. You cannot break up a square root like that over addition and subtraction, and you can't go the other way, okay? You can only do this kind of thing here, right, when you're multiplying or dividing. It's the only time you can combine them like that. So make sure you understand that, all right? Okay, everybody has that. Let's flip back to page 8. And they want us to evaluate some expressions here. And again, you got to think about order of operation, right? MDOS, okay? So for the most part, we work like they say, from the inside out with these things, okay? You guys know what these brackets mean around the x minus 8, right? Somebody tell me what that means. You've seen it before.
Absolute value.
Absolute value, right? And so absolute value always has a result that is what? What's always the result of absolute value? I'll give you a hint. It's a little like the result of squaring anything. You always get what kind of number when you take the absolute value of something?
Positive.
Positive number, right? So if whatever's in there is positive, it comes out as a positive. If whatever's in there is negative, it comes out as a positive, right? Okay? So let's answer these questions here. Part A, what operation would you do last in this expression? Of all those operations that are getting done, if I was to plug in something for x, what would be the last operation you do to it? Because we're working from the inside out.
Dividing
No, not dividing.
A root.
The square root would be the last thing you do, okay? So the square root. Okay? And a reminder, I don't think I said it yesterday, but this horizontal fraction bar, right, you all know that means division, right? But be very clear. When you have a horizontal fraction bar, it means division, but it's also a grouping symbol, like parentheses, okay? So like if you were to do, you know, this stuff divided by all that down there in your calculator, you would have to use parentheses, okay? Everybody with me? So those horizontal fraction bars act as a grouping symbol, like parentheses. All right, so let's go over to part B. Let's evaluate that expression for when x equals 2. So let's just plug it in. So we get the square root of absolute value 2 minus 8 over 5 times 2 squared plus 4. Okay? So let's work on the top part there. What is 2 minus 8?
-6.
-6. So we have the absolute value of -6 over 5 times 4, right? My screen's dancing around for some reason. Plus 4, okay? So we're doing order of operation, working from the inside out. All right, now, what's the absolute value of -6?
+6.
+6 over 20 plus 4, right? And so what's the next thing we do? What operation we're going to do next?
Addition.
Addition, right? Over 24. Okay. Can we reduce that? Reduce this fraction? Might be helpful. Divide top and bottom by what?
Divided by 6.
And you get what? 1 over 4? And now we can apply the division property, right? I showed you on the previous page. You won't always have to show this, right? But I can break this up now as what? Square root of 1 over the square root of 4, right? What's the square root of 1? 1, and the square root of 4? Is 2, right? So plus or minus 1/2. Okay, so that's your order of operation. All right. Does anybody have any questions on that example we just did? I know a lot of you get sloppy with the order of operation. We've got to be clear on that. So let's go down here, and I want you guys to evaluate your exercise 3, this expression here, when x equals 10. Okay, so I want everyone to take a minute, plug it in. Right, it's multiple choice, but I do want, you see the work I did up here, the way it looks, everything connected with an equal sign. I really have full sentences here, right? So plug it in. Careful with the order of operation, see who gets this correct. All right, somebody here says they got 31 or choice 1. Does anybody agree with that, or somebody get something different? All right, well, it is choice 1, 31. Okay, so let me run through this real quick, make sure everyone understands it. So we're just going to plug in, and my screen is sharing, right? Okay. So absolute value of the square root of 4 times 10 plus 9, and outside there's the x squared, all over 3. All right, I guess I gotta go. This is so big. So let's do our order of operation. Absolute value of square root of 40 plus 9 minus 100. All over 3. Absolute value of the square root of 49 minus 100 over 3. And the square root of 49 is 7. Make that not look like 17 over 3. And 7 minus 100 is negative 93 over 3. And what's the absolute value of negative 93? Positive 93. Okay? And then 93 divided by 3, of course, is just 31. Okay? So it would be choice 1 here. Does anybody have any questions on that example? Okay? And again, like at some point, you make sure you're fluent at this. You're not going to have to show every single little kid step here, right? Eventually you could just like do this square root of 40 plus 9 in your head and just call it 7, and skip down to the next step or what have you, okay? And we'll all know what you did, assuming we're fluent in it, okay? So does anyone have any questions on working with these square roots? Okay? Make sure you know this over here on this page, these properties. Know that you can split up and combine square roots with addition or multiplication or division, but not with addition or subtraction, okay? Just please make sure you understand that. Does anybody have any questions then? Because I will end it right here. You don't? Okay. Well, you have an assignment then in your blue book. It goes, what is this? This was Unit 1, Lesson 3, I believe, right? So again, instead of coming back, because I have to go somewhere, to go over the homework later this morning, we will do it first thing in the morning. All right, remember, don't upload it and turn it in yet until after we go over it. You've had a chance to fix whatever you have to fix, right? And then you can turn it in tomorrow. All right. So if there's no questions, we will catch you all tomorrow morning at 8 a.m.